is on mute, so
The computer is on mute, so okay. So you did it this way here. This?
yeah.
There we go. Oh, now it's gonna start crashing again. So here's the idea. If we took something we could do the area of, and we're going to look at, and now with an integral, we're going to put numbers here. So let's say I go from 1 to 2 of a function that we can easily graph, which is 2x plus 1. This is what a definite integral is going to look like. Algebraically or graphically, 2x plus 1, well, that has a y-intercept of 1, and you go up 2 over 1, up 2 over 1. And this is the line (2x plus 1). And if we looked at the area under that curve from 1 to 2, it would look like this, and it would have shapes that you know how to calculate. For example, if I draw a dotted line across here, okay, if I draw a line across from there, this makes a rectangle, and we would know that this rectangle has a length of 1 and a height of 3, so its area is 3. And this little part makes a triangle, which still has a length of 1 and this time has a height of 2, and base times height divided by 2 would tell us this has an area of 1. So we could say that that whole shape under that curve has an area of 4. And we didn't need calculus for that, because it was a nice shape. But we're going to look at if you worked backwards. This would be an integral that would be easy to do. Working backwards from x squared, add 1 to the exponent and divide. I hope you can see that that would be x squared. And working backwards from the 1 would be an x. And with the definite integral, we won't do a plus c. Because what the idea is if you plug in a number, like if I plug in 2 squared plus 2, that tells me the area from 2 down to 0 is going to be 6. So what the definite integral tells us is when you plug in a number, it figures out the area from that number all the way down to 0. If I want to find just this area, I would have to take the area all the way down to 0 from 2 and then subtract this area from 1 down to 0. And if I wanted to find the area from 1 down to 0, I could plug 1 in here, and I would get 2. So for example, what we're going to have as notation, we're going to put the integral after we've done it in square brackets, and not put the plus c, because if you had a plus c and you have one area minus the other area, the c's would just cancel out, because c minus c. And we're going to write a little 1 here and a little 2 here, which tells us, first, plug in 2. If you plug in 2, you would get 2 squared plus 2. Then subtract and plug in 1, 1 squared plus 1. And we get the same answer of 4. Of course, in this situation, it'd probably be just as easy, if not easier, to figure it out ourselves because the line was nice and straight. And when you separated the area into parts, you got a rectangle and a triangle. But what if you had something that wasn't as nice? Well, that's what we're going to look at. But first of all, to put this more formally, we call this the definite integral because unlike the indefinite integral, which had a plus c, the definite integral has an answer. And it's always going to be a value, and that value is going to introduce the area of the curve between the lower limit and the upper limit. So what do? First we find the indefinite integral, don't have to write the plus c, put it in square brackets, and write the number a and b, and then plug in b, plug in a, and subtract your results. And you will always get the actual area under that curve. So here's our first example. Recognize 3 over x as 3 natural log of x as the integral. And we would write from 5 to 2, so we don't need to write a plus c in the definite integral. Then you would plug in 5, and you would plug in 2, and you would get the area. Three natural log of 5 minus 3 natural log of 2 is approximately 2.75. Now what I'm going to show you is on your calculator. I'm going to go to y equals, and clear this out, and I'm going to graph 3 over x and show you what that graph looks like. And then what we want to find is what is the area under this curve from 2 to 5. And that isn't so easy to calculate any other way because the 3 over x graph is curved. On your calculator, above the trace button, if you have a graphing calculator, second calculate, number 7 is an integral, and it says do your lower limit, you can push 2. Do your upper limit, you can push 5. It'll shade that area in for you, and you can see that it gives you the exact same value that we got. The only problem with the calculator is this is an approximation, and in university they'll probably want an exact value, so they would probably have this as an answer, or they would use their log laws to combine this as a single logarithm. Put the 3 in as an exponent, so that'll make 125 and 8, and then a log minus a log. Your log law says you divide. So this would be the single logarithm answer that's an exact value. 2.75 is an approximation. So what the definite integral gives us is, again, practice with integrals, because we have to do all of the same integration that we've done in the past. And then the new thing is now you're plugging in values, and the result is pretty cool that you're finding an area under something that otherwise might not have been easy to see. Like, what does x plus 1 over x squared look like? Well, we can go to our graphing calculator. A little bit interesting looking. And we want to find the area from 2 to 4. So I'm going to even change my window to go up higher because I don't even see. There we go. So from 2 to 4, we want to figure out what this area is here. So if on our calculator, we can calculate number 7 from 2 to 4. That's the area we're trying to find. The answer is 22.9. We're going to see if we can figure that out without a calculator. So we need to be able to figure out this integral. First of all, I notice I have a function inside of another function. Okay? So part of my brain might go to substitution. But there's no, the derivative of the inside doesn't appear somewhere. So then, if that doesn't work, I might think integration by parts, or I might go, is there a way I can manipulate this equation so it's not in a form that I don't like? And the answer to that is yes. This isn't too bad to actually square, right? Square is multiply by itself. And if you distribute, you're going to get x squared plus 1 plus 1 plus 1 over x squared. So this is the same as the integral from 2 to 4 of x squared plus 2 plus 1 over x squared dx. And the reason this is nice is all of those are easy integrals to do. We're going to get x cubed over 3 plus 2x minus, or I can write it as plus, add 1 to the exponent. So if I have an x to the minus 2, adding 1 would be an x to the minus 1 divided by that minus 1. And now we could plug in values. So plugging in 4 cubed divided by 2, 2 times 4 would be 8, minus 1 over 4. And then subtract, plug in 2. 2 cubed is 8, plus 4, minus 1 over 2. Oh, and this is over 3, sorry. That's a 3 and a 4. And we could, of course, do this with mental math. I'm going to cheat and use my calculator. If you got a common denominator and put everything together, you would get 275 divided by 12, which, if you type that in, is 22.9, which matches what we saw on our graphing calculator. So for the next couple, I have the answer written down with picture, as well as we'll do it by hand. Okay? So the first thing that we do in a definite integral is we put square brackets and we integrate like normal. And I will pause and give you like a little bit to try to integrate this one first on your own, or at least try it in your head. Then I'll put up the answer in a second. And you can check how you did. Did you remember to divide by the 3 with the e to the 3x? Now, as an exact answer, the exact answer, the best you could do, see this part you couldn't evaluate in your head. This part you couldn't evaluate in your head. But the right-hand side you can evaluate in your head. The right-hand side is just 1. E to the 0, anything to the 0, oh sorry, the right-hand side is just 1 there. E to the 0, anything to the 0 is 1. So this will be 1/3. Natural log of 1, log of anything to the 1 is really asking, right? You imagine there's a little e as a base here. You're trying to solve the exponent. E to what exponent is 1? Well, anything to the exponent of 0 is 1. So this part equals 0, and you would just have 1/3 minus 0. So the second part just becomes minus 1/3. And if you type this into your calculator and check its value, it would match up with a little diagram in the bottom and have a value of 4.97. Which, if we think of that graph, first of all, that graph is crazy. Second, it has lots of curves, and now we have calculated its area exact, despite the fact that it has all those curves. This one is interesting. Oh, and if we can do integrals with sine and cos, and we can do definite integrals, we're going to need to know our pi plate or unit circle values for these ones. So first of all, we integrate. And you can check if you got your integral right. And then we plug things in. So first of all, we'll plug in pi over 2. And then we subtract and we plug in pi over 6. So on our pi plate, we'll have 3 pi over 2. Cos of 3 pi over 2, cos is your x coordinate, it's 0. Beautiful. Minus. Plug this in, simplifies to pi over 2. Is also 0. Take out your calculator. Crazy. How can you get an area of 0? Look at the picture, and the picture shaded definitely has something shaded. So the question is, how does this work out to 0? Interesting, the calculator, I don't know if you can see the number that, and if you did this on your calculator, you might get a different number than my calculator, and then it really bothers your faith in your calculator a little bit. What does it mean if it has negative 1.07 e to the minus 14? Well, that e to the minus 14 is times 10 to the minus 14. So you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then on the 14th digit would be the 107. Approximately, what is this number equal to? 0. Okay? The calculator doesn't know calculus. So you can, if you need an ego boost, you can take out your calculator and say, I'm better than you in some ways. Right? If you need that, It's there, because the calculator, it does a ton of calculations until it gets exhausted and says, I think we're close enough. And my calculator got close enough at 0.00000000000000000000001 and it was tired. Which, rounded, is basically 0. We use calculus and we found out it is supposed to be exactly 0. So depending on where your calculator started calculated and when it tells itself it's close enough and how much memory it has, different calculators will get different values for this. And some of them might even say 0 sometimes, be like, yeah, I think it's 0. So it's interesting. Now, we are going to find out why this is 0, because when you do the definite integral and you calculate areas that appear above the x-axis are going to be positive. And areas that appear below the x-axis are going to be negative. And because your sine and your cosine graph are so nice and symmetrical, you often get that the area below would be exactly the same as the area above, which is what happened in this case. And so the same number minus the same number would give you 0. All right, once again, check how you did. On your integral, you have to add 1 to the exponent. This is an ax plus b form, which if you did the chain rule of the derivative, you'd have to multiply by 2. So integrating, we can do this without substitution by just also dividing by 2 to get rid of that simple chain rule. Now, initially, if you were thinking about this question, initially you might say, Mr. Jared, did you make a typo? Because you're now trying to find the area from 3 and going to 2. And normally, when we're finding the area between two things, we'd have the lower number first and the upper number second. So this seems wrong, like as it's a typo. It wasn't a typo. You are allowed to do that, okay? Now, if normally what's happening is, if you had from 2 to 3, it would calculate the area from 3 down to 0, and then subtract the area from 2 down to 0. Now this one being backwards, first would calculate the area from 2 down to 0, and then subtract the area from 3 down to 0. So the result would be the same area, except one of them is going to be negative, and the other one's going to be positive. So we're going to see what happens in this case. I'm going to plug in 2. We get negative 1 to the 5 over 10. Then plug in 3. We get 1 to the 5 over 10. And our result is 1/10, negative 1/10 minus 1/10 is negative 2/10, or negative 1/10. So what I'm going to do on my calculator is I'm going to graph this one to show you. Y equals, clear this out, bracket 2x minus 5 to the power of 4. That's what we started with. Good. There's our graph, and we want to see the area from 2 to 3. So first of all, I'm going to calculate it, number 7, with my lower one 2 and my upper one 3. And I get positive 0.2. I'm going to check if my calculator would let me do that if I put my lower as 3 and my upper as 2. This seems like it shouldn't work. It might be my calculator tells me an error here saying you put your lower number bigger than your upper number. That bothers me. But if it's calculating it the same way that we are, it should come up with negative 0.2, and it did. So it's not necessarily following its rules either, because we put the lower number as bigger than the upper number. But the results would be the same, just one will be positive, one will be negative. So it's not impossible to do a lower number bigger than an upper number. And it's also possible to do them to the left of your y-axis. So if we were doing from -2 to 0, this, okay, we would get x squared over 2 minus e to the minus x over minus 1, square bracket that. And our answer would be -1 minus e squared. So we're going to end by looking at the properties of the definite integral, some of them that we may have noticed already, and some of them that may become obvious, especially when we think about area under the curve. Okay? First property, if you find the area between A and A, that's just a straight line with no width whatsoever. It's going to be 0. There's no area when you have a one-dimensional line there. Okay? We saw this already, that if you switch your A and B in other directions, they're going to be the same number, but one is positive and one is negative. If you found a point in between A and B. So for example, let's say I have a nice parabola, and here's A and here's B. The integral would find this area. If I introduced a value C in between them, does it make sense that the area from A to C plus the area from C to B would be the same as the whole area together? So we can break up an integral if we want to, and we're going to want to do this in some cases, that the entire area would just be the same as breaking it up into 2 areas and adding them. When you see the picture, it makes total sense. And that is what it looks like when you're talking with integrals. And just like properties of indefinite integrals, if you have some constant, you can pull that constant out in front. It's the same as if it was inside or if it was outside, and the same thing with indefinite integrals. If you're adding or subtracting inside, you could do the integrals separate. The same thing happens with definite integrals.